Dear students, welcome to our learning session today. In this lecture, we will take a part of basic statistics, that is moment, skewness and kurtosis. We will see here what is moment, what is skewness and what is kurtosis over here. Now, in our previous lectures, we have learned measures of central tendency, measures of dispersion and quartile deviation as a part of our basic statistics. Okay, so this is one more topic on moment, skewness and kurtosis, which is again a part of this chapter, that is basic statistics. Here we will use the previous concept which we have already learned. Some of the concepts, basic concept, like we have to find the mean or we have to see the value of assumed mean, that all things we will need here. Now first let us see what is moment. For ungrouped data of n observations, x1, x2 up to xn, these are the n observations given to us, and an arbitrary constant capital A, which here it is in bracket, it is written as at origin. The earth moment about A, the earth moment about A is given by QR dash is equal to 1 upon n summation I equal to 1 to n xi minus a raised to r, where r is 0, 1, 2 up to infinity. We name this as equation 1. See, again I am repeating, this is what earth moment about A. A will be given to us, that is about origin or about mean, whatever it is given to us. Accordingly, we will take our capital A. And that will be what? That will be obviously constant. Okay. And this is given by mu r dash, where this small n is the number of observations. Since it is, we are finding here for n observations, right? Now next is for simple frequency distribution, that is when xi, fi's are given to us. Then the earth moment about A, earth moment means we are writing here mu r, so we are taking earth moment about A is given by 1 upon capital N into summation I is from 1 to n fi into xi minus a raised to r, where r is 0, 1, 2 up to so on. And we know that capital N is summation of fi's. Now see, the moments mu r dash are also known as row moments. What are these known as? These are known as row moments. Now to make simple calculations for frequency distribution, we can also use the following formula. This formula can also be used, that is mu r dash is equal to h raised to r upon capital N, where capital N is summation of fi's, into summation fi into bi dash raised to r. Now what is bi dash? We have learned this in mean, xi minus a upon h, where this a is what? Assumed mean, right? We name this as equation 3. Okay, obviously you will not get much more idea just now. When we will move towards the examples, you will learn how to use these formulas. Now this was about origin, right? Now what is the next topic? The next topic is moment about mean, where we are taking A as x bar, right? X bar means arithmetic mean, simple mean. The moments in equation 1 and 2 are called the earth moment about mean, or you can say central moment, and it is denoted by mu r. See, that was what about in first two equations we are talking about origin or about something A, where A is okay, about origin. But here you are talking about what? You are talking moment about mean. So that is given by mu r. There is difference between mu r dash and mu r, right? So mu r is equal to 1 upon n. We will just replace a by x bar. See the difference in equation 1 and equation 4. There you are writing capital A. Here you are replacing capital A by x bar. Similarly, mu r for frequency distribution can be written as 1 upon capital N, where we know that n is the summation of fi's, right? Which is given by I equal to 1 to n fi into xi minus x bar raised to r, where r is 0, 1, 2 up to so on, integers, right? Again here what we are doing? We are replacing a by x bar. Okay, now if we are taking r equal to 2, so you get mu 2 equal to 1 upon n summation fi into xi minus x bar whole square. This is equal to what? This is equal to sigma square. Sigma means what? Sigma means standard deviation. Okay, and sigma square means what? Variance. You can see this similar formula in standard deviation, where we used to write here raised to 1 by 2, something like this you are writing there, right? So this is sigma square, and that is what? Variance. Now let us see here. We are taking, see, first two equations were general equations, right? 1, 2 and 3 were general equations. We are taking about some A. Next we seen that we are finding moment about mean. Remember? Okay, now here we are taking moment about origin, or you can say moment about 0. So we are taking, replacing a by 0, and it is defined and denoted by what? Mu r dash, sorry, we are taking v r dash, which is equal to 1 upon capital N summation fi into xi raised to r. See here we are replacing this x bar by 0. Okay, so when we are replacing x bar by 0, so the term of left over will be fi into xi raised to r, and where capital N is sum of fi's. Now let us see the relation between mu r, that is moment about mean, and simple mu r dash, that is moment about a. And here we are taking, we will see the relation between moment about mean and about 0, right? So relation between mu r and mu r dash is given by mu 2 equal to mu 2 dash minus mu 1 dash whole cube. Mu 3 is given by mu 3 dash minus 3 mu 2 dash mu 1 dash plus 2 mu 1 dash whole cube. Mu 4 is given by mu 4 dash minus 4 mu 3 dash mu 1 dash plus 6 mu 2 dash into mu 1 dash whole square minus 3 into mu 1 dash raised to 4, where x bar is equal to mu 1 dash plus a. We will see this how to use in various examples. Okay, for a moment you just remember this formulas. Now relation between mu r and vr dash. See, v1 dash is given by a1 plus mu1 dash, which is equal to mean. Next is mu 2 dash, which is equal to mu 2 plus v1 dash whole square. v3 dash is given by mu 3 plus 3 v1 dash into v2 dash minus 2 v1 dash whole cube. And the last one, v dash 4, is given by mu 4 plus 4 v3 dash into v1 dash minus 6 v2 dash into v1 dash whole square plus 3 into v1 dash raised to 4. Now let us see what is skewness. Our next topic is skewness. We will see all the examples together, because for skewness we will need how to find we will need to find mu1 and mu2 also, right? So skewness measures the degree of asymmetry for the shape of frequency distribution. What does skewness do? It measures the degree of asymmetry. That is, it indicates that the distribution of items on it is not symmetrical, right? And what is coefficient of skewness? Coefficient of skewness based on central moment is given by beta 1 equal to mu 3 square upon mu 2 cube. And this is suggested by whom? By Karl Pearsons. Now there is one note written over here. If the coefficient of skewness is positive, then the frequency distribution is called positively skewed. If it is negative, then the distribution is called negatively skewed. And if the coefficient is 0, then the distribution is called symmetric distribution, right? Now next is, what is kurtosis? Kurtosis measures the degree of skewness. See, what does skewness do? Skewness measures the asymmetry. And what does kurtosis do? Kurtosis measures the degree of skewness of a distribution. And it is given by beta 2, which is equal to mu 4 upon mu 2 square, where beta 2 equal to 3. If the value of beta 2 is 3, then the curve is normal, that is symmetric, and it is known as mesokurtic. If the value of beta 2 is greater than 3, then the curve is more peaked than the normal curve, and it is known as leptokurtic. And if beta 2 is less than 3, then the curve is less peaked than the normal curve, and it is known as platykurtic. Now we will learn these formulas by seeing the examples. Our first example is, find the first 4 moments about the mean. You have to find first 4 moments about the mean. So to find about the mean, you just need the formula of mu r. Remember this, about mu r, okay? First we find the mean. We need the mean. Okay, so we will find the mean. So mean is given by x bar equal to sigma xi upon n. We will add these all terms and divide by total number of terms, that is 5. You get our mean as 8. Now here we will use equation 4 from the first theories, earlier theories which we have learned. There in equation 4 the formula was mu r equal to 1 upon n summation xi minus x bar raised to r. Here you have to find 4 mean, first 4 moment. So r will be equal to 1, 2, 3 and 4. See, first we will find the values of x. See, this table method will be much easier for us to calculate these terms. Okay, so first we will write all the values of x. Now we will minus this from the mean. So our mean was what? 8. So 5 minus 8, that is minus 3. 10 minus 8, that is 2. 8 minus 8, that is 0. We will do this for all and we will add it. You get your answer as 0. Now we will square here. See, this is for first moment, this is for second, this is for third, and this is for fourth moment. For second moment, you will need the square of these values. So 3 square will be 9, 2 square 4, 0, 0, 5 square 25, and so on. We will add this term, you get 54. Next, you will cube this term, minus 3 cube, minus 27, 2 cube 8, and we will do this for all the terms, and at last we will add and you get as 42. Now we will take the fourth power, you get 81, 16, 0 and so on, and you do the total, you will get 978. Now see, in the previous formula, we'll put the values of r. So values of r we are taking as r equal to 1, r equal to 2, 3 and 4. So when you take r equal to 1, you get mu1 equal to 1 upon n, where n is 5. Summation of xi minus x bar. So summation of xi minus x bar is 0. So you are putting this 0 over here. So mu1 is 0. That is your first moment. Now when you put r equal to 2, you get mu2 equal to 1 upon n summation xi minus x bar whole square. So n is 5. the second column total is 54 that you are putting over here. So 54 by 5, that is 10.8. Next, we are taking r equal to 3. So you get 1 upon 8 summation xi minus x bar whole cube. Again, n is 5. You will take this value and you will substitute here. That is 42. You get your third moment as 8.4. Similarly, when you put r equal to 4, you get mu 4 equal to 1 by n summation I equal to 1 to n xi minus x bar whole raised to 4. Okay, so that is 978. You will substitute here. N is 5. So you get your fourth moment is 195.6. So these are the first 4 moments about mean which we have calculated according to our given values of x. Now let us move on another example. Next question is, find the first 4 moment about arbitrary origin for the data of the individual scores in the cricket tournament. See, now here which formula you will use? It is the about arbitrary origin, not about 0. It is about arbitrary origin. Okay, so you will use the formulas from mu r dash. And which formula you will use? You will use the formula of class interval, that D formula you will use. Okay, so here we are using equation 3, that is mu r dash equal to h raised to r upon capital N, which is the total of frequencies, that is total of players, right, into summation I equal to 1 to n Fy di raised to r di dash, where di dash is what? Xi minus a upon h. See, here a is 75. I'm saying you how it will come. Okay, so a is 75 and h you are taking as 10 because the interval difference is of 10. See, now we will calculate here. First we will construct a table. Okay, again here you will take the value of r as 1, 2, 3 and 4. So first we are taking class intervals. Next we will calculate xi. How to calculate xi? 50 plus 60 divided by 2, that is 55. Next 60 plus 70 by 2, that is 65. Similarly we will calculate for all. And what will be your capital A? Capital A is assumed mean, that you are taking from the xi. Okay, the middle term from xi will be your A. If there are 2 middle terms in xi, you can take either of the term. These fi's are given to us. Now see, mu1 dash is what? H upon n sigma fi d dash. Okay, so now h is what? 10 capital N, that is summation of f, that is 50. Next you will need to find di. Di is xi minus a upon h. So di, when you calculate first time, xi minus a upon h. Okay, see, xi is what? 55 minus a, that is 75, divided by h, that is 10. So this will be 55 minus 75, that is minus 20 by 10, which is equal to minus 2. So first will be minus 2, then you keep on increasing the terms. Minus 1, 0, 1 and 2. Now I will multiply fi into d dash, that is 8 into minus 2, 16, 11 into minus 1, that is minus 11, and so on. And I will do this total over here. So the total is minus 10. Simply I will substitute in this formula. You get 10 into minus 10 upon 50, that is equal to minus 2. So this is your first moment. Now next, mu2 dash. Mu2 dash is equal to, you take r equal to 2. So h square upon capital N into sigma fi d dash square. Now what you have to do is, it is d dash square. Multiply this, do the square of d dash. So 2 square will be 4. 4 into 8, that is 32. Similarly, find all these values and add it. Okay, so on adding you get 68. So we'll put these values over here. h square, that is 100 upon n into 68, which is 136. Now next, you are taking r equal to 3. So for r equal to 3, you need fy d cube. So first find the cube of d. Okay, so cube of d will be 64, 2 to the 4 to the 8. 8 into fy, that is minus 64. Do this thing for all the terms. Add this, you get minus 34 and simply substitute in this formula. So h is 10, 10 cube is 1000, capital N is 50 and this will be minus 34. So you get your third moment as minus 680. In the same way, we are taking r equal to 4. You get mu dash 4 equal to h raised to 4 upon capital N into fi d dash raised to 4. So first, take the fourth power of d dash and multiply it with 8. You get 128. Do this for all the values of f d dash 4. Find the total, that is 212, and put in this value. You get your fourth moment as 424. Now let us move towards the next example. The first four moments of distribution about arbitrary origin are 2, 13.2, 59.6 and 330. Find the mean, variance and comment on the nature of distribution. See, this question is a bit different from the previous ones. What it is given to us? Find the first four moments of distribution about arbitrary origin. See, what formula we will use here? It is given us that about arbitrary origin. So we need to use the formula of mu2, mu3, mu4 and x bar. Okay. So here about arbitrary origin 4 it is given. So A will be equal to 4. And 4 moments are given to us about arbitrary origin, that 2, that is mu1 dash will be 2, mu2 dash will be 13.2. Next value is 59.6, that will be mu dash 3. And last is 330, that is mu dash 4. Now we have to find mean and variance. So mean, according to our formula, mean is given by x bar equal to mu1 dash plus a. Mu1 dash is 2 and a is 4. So our mean is equal to 6. Now next, we also have to comment on the nature of distribution. So we need to find other four moments. Okay. So mu2 dash equal to sigma square, which is variance. So formula is mu2 dash minus mu1 dash whole square. So mu2 dash is equal to 13.2 and mu1 dash is equal to 2 and its square will be 4. So that will be equal to 9.2. This is our variance. Now mu3 will be equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash whole cube is equal to, we will put values. mu3 dash is 59.6, mu2 dash mu1 dash is 13.2 and 2, and mu1 dash whole cube, that is cube of 2. Okay, on simplifying this you get mu3 equal to minus 3.6. Now next, mu4 is given by mu4 dash minus 4 mu3 dash mu1 dash plus 2 mu1 dash whole square minus 3 mu1 dash raised to 4. Now we will put all the values over here and you get mu4 equal to 122. Now see, we have to comment on its nature. So we will find beta 1 and beta 2. See, beta 1 is given by mu3 square upon mu2 cube. We'll put the value of mu3 and mu2 which we have found just now, and on simplifying this you get here as 0.0166. Since beta 1 is greater than 0, the distribution is positively skewed. Okay, if it is less than 0, then it is negatively skewed. Now next is beta 2. beta 2 is given by mu 4 upon mu 2 whole square. Okay, so mu 4 is 122 and mu 2 is 9.2 and its square. On simplifying this, you get 1.44. Now here the condition was about beta 2 equal to 3, beta 2 less than 3 and beta 2 greater than 3, which we have discussed just before. Okay, so here beta 2 is less than 3. So the distribution is Platy-Kurtic distribution. So this example was regarding the classification of its distribution. Now let us move towards the other example. In a distribution of two different groups, the variance are 15 and 27. Here there are two groups, group 1 and group 2. And variance are given as 15 and 27. Okay. So if we consider for group 1, the variance, that is mu 2, is given by sigma square is equal to what? 15. Whereas, now let us move back towards the question. Whereas the third central moments are 32.4 and 67.5. Now this 32.4 is for group 1. So third central difference. So mu 3 is equal to here in solution 32.4. Now what we have to do is compare the skewness of two groups. We have to compare the skewness. Okay. Now so beta 1 is given by mu 3 square upon mu 2 cube. See, mu 2 is given to us, mu 3 is given to us. We will just put here and you get as 0.311. Now mu 1 is given by what? Under root of beta 1. So that is equal to under root of 0.311, which is equal to 0.5776. Similarly, we will find here for group 2. For group 2, mu 2 is given by sigma square, which is equal to 27 and mu 3 equal to 67.56. So again we will apply the formula of beta 2. Mu 3 square upon mu 2 cube. We'll put the values over here to get as 0.231. Therefore, beta 2 is given by under root of beta 2. We'll find under root of 0.231. You get your answer as 0.480. See, now you have to find, we have to say which is more skewed. See, here you are getting mu 1 as 0.5776 and here you are getting mu 2 as 0.480. Whichever is less will be more skewed. So here mu 2 is lesser than mu 1. So you can say that group 2 is more skewed. So dear students, this topic was regarding moment, kurtosis and skewness. So you must be clear with the topic. Thank you.